So we've been introduced to the idea of the method of substitution, but there's some things about how to use u-Substitution. And there are 6 steps, and this is not an exhaustive list, and frankly will not work for every integral out there. So keep this with a grain of salt. There are some edge cases, but this is sort of a general list of how to do this. And when you encounter something for which this does not apply, we'll go from there. So the first thing you want to do is the first thing to do u-Substitution is to try not to. And that sounds odd, but the problem that I've noticed over the years with students is once they learn a new technique in integration, and by the way, substitution is not the only extra technique. Once they learn an extra technique, that's all they want to do. They just want to keep applying that technique to whatever problem they're working. And frankly, that's not correct. What you need to do is become comfortable with the techniques so that you can use the ones you need to use. And so anyway, if you can directly integrate this without substitution, do that. Don't waste your time. So the next thing is to, a lot of the students, this is probably the hardest step, honestly. It's figuring out what to choose when evaluating. And it's oftentimes it's, all right, so maybe something in parentheses or something in a denominator. Those are very common choices. They're not the only choices. And sometimes they're like an argument of a function. So like if it's cosine of 2x plus 5. Now, you might think of that as being in parentheses, but it's really an argument. So usually that's what you would do. You want to choose that and see if that works, but it may not. So what you're going to find is it's kind of an iterative process. The next thing you want to do, and this is something that's a little hard in the beginning, but gets a lot easier as you do it, is once you've chosen what u is going to be some function of x. Now this, by the way, doesn't have to be x. It could be an integral in t or an integral in w. It doesn't matter. But for our purposes, we're going to say it's x. So the next thing you want to do is find the derivative of that expression with respect to x. So you're going to have u equals something, and then you're going to have du dx equals the derivative of that expression. And then you're going to take the denominator and move it over to say du equals something dx. Du equals whatever that derivative was, dx. And that's going to be your next piece. Now, if you notice that derivative that you just found, that u prime, if you can't find that anywhere in the original integrand, which is the thing you're integrating, if you can't find that in there, then you've probably chosen incorrectly, because that's going to have to get absorbed somehow. So if you choose x cubed minus 2x, and then as u, and then you take the derivative and you get 3x squared minus 2, I think I said 2x, anyway, 3x squared minus 2, and you can't find that anywhere in that integrand, then you probably need to pick a different u. So anyway, that's just a good self-check here. Now the next thing you're going to do is, instead of having it written like this, bring that over and divide and say dx equals du over that u prime. We want it to look like this. The reason we want to do that is that it's easiest to replace things directly. You just say, you have, integral sign, some expression, dx. So we want dx to equal whatever, and then so we're gonna manipulate this so that it works out, and then everywhere you can plug in a u, everywhere where you can take that original, that u of x, not u prime, but anywhere you can see that, you want to plug it in. So basically you're trying to just turn everything you can into a u to get rid of all the terms that are in terms of x. If you don't have something that only has u's left at the end, then you haven't done it correctly, because we have to completely change over into this like u ecosystem. We were in x, now we're in u. So you have to do it that way. The next thing is the easy part. You integrate with respect to u. If you've done this correctly, hopefully you don't have to do any other techniques. You just, boom, you go straight to it, you integrate. And by the way, for indefinite integrals, don't forget your arbitrary constant. And then finally, you're going to end up with an expression in terms of u. But the thing is, you started with it in terms of x. So you have to go back. So all those places you have u's, you have to replace those with terms in terms of x. Now this is up here, and we don't have any examples to go through, but I'm going to do that so I can leave this here and do examples so we can always refer back to it while we're while we're completing the examples.